Induction for finite languages is trivial. We simply use the domain closure rule of inference. For a language with object constants sigma 1 through sigma n, the rule is written as shown here. If we believe a schema is true for every instance, then we can infer a universally quantified version of that schema. Suppose, for example, we have a language with just 4 object constants and no function constants. Then we can write a domain closure as shown here. If a schema is true of A and B and C and D, then it's true of everything. The trivial proof shown here shows how we can use this rule to derive an inductive conclusion. Suppose we have the ground implications shown on premises on lines 1 through 4. Using our domain closure rule, we can then derive the inductive conclusion: for all x, p of x implies q of x. For finite languages, domain closure is really all we need. Unfortunately, this technique does not work well when there are infinitely many ground terms. In that case, we could write a domain closure rule analogous to the one we just saw. And the rule would be sound in the sense that the conclusion is logically entailed by the premises of the rule. However, it would not help us produce a proof of the conclusion. To use a rule, we need to prove all of the rule's premises. When there are infinitely many premises, we cannot do this in a finite amount of time, and so there's no possibility of a finite proof. All is not lost. It's possible to write rules that cover all instances without explicitly enumerating them. The trick is to use the structure of the terms in a language. In the following sections, we'll talk about how this is done for languages with a variety of different structures.